There is a place where light itself gives up, where the fabric of everything we call real matter, time, causality, begins to fray at its edges like the hem of a garment worn too long by a universe that has been expanding, alone, for longer than human language has the numbers to express. NASA found something there, not a planet, not a star, not a black hole swallowing its neighbors in elegant, terrible silence. Something else. Something that does not belong in a universe that was supposed to be cooling, thinning, and slowly dying. Something that pulses. In 2023, astronomers using the James Webb Space Telescope did something no instrument in human history had ever done before. They looked not metaphorically, but literally 13.5 billion years into the past. Webb's infrared sensors cut through the dust and the distance, and what they found at the earliest observable edge of our universe violated nearly every model we had built with such proud precision. Galaxies. Fully formed, spiral-structured, massive galaxies already there, already ancient, in a universe that was only a few 100 million years old. This is the equivalent of finding a fully grown oak tree in a photograph taken 30 seconds after you planted an acorn. The models said it couldn't be done that fast. Star formation, gravitational collapse, the slow accumulation of mass across millions of years, these are not shortcuts. These are the fundamental grammar of cosmic architecture. And yet, the James Webb data didn't flinch. The galaxies were there. Some of them were producing stars at a rate 500 times faster than our own Milky Way produces them today. As if something had handed the early universe a blueprint. As if someone or something had already run the math. Scientists gave this phenomenon a careful clinical name, the impossible early galaxy problem. But here's what they whispered in the margins of the papers. What they said in the hallways of Caltech and the European Space Agency's corridors in Madrid. We don't know what caused this. And in science, those 5 words are the most dangerous sentence in existence, because they are the doorway. They are always the doorway. Before we go further, we have to stop and reckon with something almost too large for human cognition to hold without cracking at the edges. The observable universe. The sphere of spacetime we can technically detect extends approximately 46 billion light-years in every direction from where you are sitting right now. Not 46 billion miles, not 46 billion kilometers, 46 billion light-years, each one a distance that light traveling at 299,792 kilometers per second would require a full year to cross. You are the center of that sphere. So is every other being in the cosmos. So is every atom in the Andromeda Galaxy. The observable universe is not a place. It is a perspective. It is the horizon of what any given point in spacetime can receive light from, given the age of the universe and the speed at which that universe expanded. Beyond that horizon, we don't know. We genuinely, completely, with no rhetorical humility whatsoever, do not know. The universe beyond what we can observe may be infinite. It may curve back on itself. It may be one of an uncountable cascade of bubble universes, each with its own physical constants, its own laws, its own version of what it means for something to exist. And here is where NASA's data becomes not just scientifically extraordinary, but existentially disorienting. Because right there, at the very edge of what our instruments can reach, at the cosmic horizon, where the light we detect is so ancient, it left its source before the Earth had atoms. Something in the structure of the universe is not uniform. It is not smooth. It pulses. The cosmic microwave background, the CMB. This is the afterglow of the Big Bang, the oldest light in existence, the thermal echo of creation itself, permeating every cubic centimeter of space at a temperature of 2.725 Kelvin. It has been mapped with extraordinary precision by the WMAP satellite and then by the Planck telescope, And what those maps show is this. The CMB is almost perfectly, hauntingly uniform. Almost. Because there is an anomaly. There is a region in the southern sky first identified formally in 2004, studied obsessively since, and still unexplained that cosmologists call simply, with the haunted economy of scientists who have run out of comfortable language, the cold spot. It is a region of the CMB roughly 1.8 billion light-years across, where the temperature is measurably, consistently, significantly lower than the surrounding universe. Inflation models don't account for it. Standard cosmology produces no mechanism capable of generating it, and several possible explanations have been proposed and one by one ruled out. One that remains on the table, published in peer-reviewed literature and not yet falsified, is the super-void hypothesis, the idea that there exists between us and the CMB an enormous absence of matter, a bubble a billion light-years wide, where the density of galaxies drops to nearly nothing. A void. A super-void. Pause on that word. Let it breathe. In a universe structured by gravity, by the inexorable tendency of matter to find matter, to cluster and collapse and coalesce, what empties a billion light-years of space? But the super-void alone doesn't fully account for the temperature drop. The math doesn't close. And so scientists, careful, cautious, credentialed scientists have written, in the language of academic restraint, phrases like, exotic physics may be required. Exotic physics. That is the scientific community's version of saying, something is here that we did not build into our equations. In 2017, a separate but related anomaly was confirmed by multiple independent teams. A directional preference in the universe's expansion. A subtle but measurable asymmetry in how the cosmos is growing faster in one direction than another. Cosmologists call it the dipole anomaly, and by the standard model, it should not exist. A truly isotropic universe, one born from a single, directionless explosion, should expand equally in every direction. Ours does not. And the direction toward which the expansion is subtly, persistently biased, points at cosmological scale toward that same anomalous region of the sky. Two anomalies, one direction. Coincidence is the story we tell when we haven't asked the right question yet. Now we must step carefully across a threshold, because what comes next is not confirmed. It is not in the textbooks. It has not been announced in a NASA press release with smiling scientists and color-coded diagrams, but it lives in the serious margins of serious science. And to ignore it because it is uncomfortable would be its own form of intellectual cowardice. Consider the Hercules Corona Borealis Great Wall, discovered in 2013 and confirmed in subsequent studies. It is the largest known structure in the observable universe, a filament of galaxies, approximately 10 billion light-years long, 7.2 billion light-years wide, and 900 million light-years thick. 10 billion light-years. It contains billions of galaxies. It is so massive that it defies the cosmological principle, the foundational assumption that, at large enough scales, the universe is smooth and uniform. Structureless. The Great Wall is not structureless. It is organized. It is geometric in a way that makes no intuitive sense, given that gravity alone operating over the available time since the Big Bang should not have been able to build something of that scale and that coherence. And yet the Great Wall is not alone. We have now mapped dozens of supervoids, superclusters, and colossal filaments that collectively form what astronomers have begun calling the cosmic web, a vast, interlocking, almost neural architecture of matter and void that spans the entire observable universe. Neural. That word is not metaphor. It appeared in a 2020 paper published in the astrophysical journal Letters, comparing high-resolution imaging of the cosmic web with high-resolution imaging of neural tissue from the human brain. The structural similarities in branching patterns, node connectivity, clustering ratios were, by the author's own measurement, statistically extraordinary. The universe, at its largest scale, resembles a mind. And a mind, in every model we have built, processes information. What if the cosmos is not the canvas on which intelligence occasionally appears? What if the cosmos is the intelligence?